Okay, today we're going to look at section 5.1, which is kind of just an extension of what we did last chapter with the equations. So if you feel pretty good about chapter 4, this should go pretty well. So if you would, notes out in front of you, and then fill this out with me. An inequality will have one of the following four symbols instead of an equal sign. It could have r less than, greater than, less than or equal to, or greater than or equal to. And we're going to remember that you must flip the inequality symbol whenever you multiply or divide by a negative. And that's something that we worked with quite a bit in chapter 3. In inequality, anytime you multiply or divide by a negative, the symbol, if it was less than, it turns around and now it's greater than, or greater than, it turns around and now it's less than. So we might have to do that somewhere there. When we solve a linear inequality, we're going to follow these steps. First thing, we will graph the related linear equation. So we'll kind of treat it as if instead of an inequality, it's an equation. We'll graph that like we did last chapter. Typically, we will want to write the equation in slope-intercept form, if it is not already as such. And again, just like last chapter, this means we get the y by itself. And sometimes it'll already be like that. We can go ahead and graph it as it is. If it's not, we do the algebra, we move everything else other than the y, and then we move on to step 2. If the inequality is just less or greater, we will make a dashed line. So the line, instead of being solid, it'll look something like that. We do that to represent that the line isn't part of the solution set. If the inequality is less than or equal to, or greater than or equal to, then the line will be solid. So like that. So again, less or greater, dashed. If it's less than or equal to, or greater than or equal to, solid. That's like in chapter 3, if it was less or greater, we left it open. And then if it was less than or equal to, or greater than or equal to, we closed it. But now since we're dealing with a line, we're going to make it either dashed or solid. And then third step, you must shade in an area above or below the line. To figure out where to shade, test a point not on the line. Usually, we're going to use the point 0, 0. It's easy to use 0, 0 because plugging in zeros makes the math as simple as possible. The only time we will not use 0, 0 if that's already on the line. Then we just pick something else. When we plug it in, we see if it works, then we shade that part. If it doesn't work, then we shade the other region. So we're going to look at 6 examples, and then I'll give you some to try out on your own. So go ahead and turn the page. Example 1, we're going to graph the inequality. If you look at this, you'll probably see that the y is already by itself. So this is in slope-intercept. So when I graph it, I just look at b is the 4, and then m is the negative 3/4. So that would tell me when I graph it, I need to start at my b, which is at positive 4. So my first point will go 1, 2, 3, 4 up there. Then I look at my slope. It tells me to go down by 3, over by 4. And then I'd repeat that at least one more time. Down 3, over 4. Before I make the line, I'm going to think about step 2. Since it's just less than, I'm going to make that a dashed line. Then I've got to figure out where to shade. I look at my graph. 0, 0 is right here, and that's not on my line, so I can try that out. I'm going to plug in a 0 for the y, less than a negative 3/4. Plug in 0 for the x, plus 4, and see what happens. If I take the negative 3/4 times 0, That cancels. So I get 0 is less than 4. And I've got to think, is that true? So ask yourself, is 0 less than 4? That's true. So that means that this point is part of my answer. So I would shade everywhere that that's part. That graph is the answer. It's that dashed line and then everything underneath. So that's complete. Next one actually ends up being a little bit easier. Y is greater than or equal to 4. We're going to remember if it's y by itself, that means that is a horizontal line. It's a positive 4, so I go up on the y-axis, put my 4, and then I'm going to look at my symbol. It's greater than or equal to, so that would mean it's a solid line. And then if it's a horizontal one, it's pretty easy just to think, if we need to be greater than that, we should be above the line. So I'm going to shade everything that's above that. So that's my answer to this one. This solid horizontal line, and then everything that's up above that. Next page, example 3. This time it's x equals something, so we're going to remember that that is a vertical. So I look, it's a -4, so I go over on here to -4 on my x-axis. I notice that it is less than, so that means I need to make that a dashed line. And if I want everything that is less than -4, that would be everything to the left. And that's kind of like how it was in the last chapter. As long as you can remember when it's just y equals something, it's horizontal. Whenever it's x equals something, it's vertical. Those should be the easiest two to get. Example 4 is going to have a little bit more work. When you look at this, I hope you recognize the y is not by itself. So before we can graph, we need to get the y alone. So what we've done before, we look at, circle the y, move the other stuff. So I can add 3x. That's gone. Bring down everything I didn't use, the 4y. Didn't do anything to change the symbol. Positive 3x, positive 12. And remember, we can't combine the 3x and 12 because they are not like terms. We still need to get y by itself. So that 4 is multiplying, so divide to get rid of it. So that would cancel. So y is less than or equal to 3/4 x plus 3. Once you've done that, it's identical to what we've been doing. We're going to look at it. The b is 3, so I would plot on my y-axis a positive 3. The slope is a positive 3/4, so I would go up 3 over 4. Up 3 over 4. And then I'm going to go backwards at least once. So this gives me a good idea about what that line would look like. And then you'll notice I made that line solid because in my problem it was a less than or equal to. Because it could be equal to that, it gets a solid line. To test it, I'm going to go back to the original problem. I'm looking at 0, 0. It's not on my line, so I can use it to plug in. So it's -3 times 0 plus 4 times 0 less than or equal to 12. So that gives me 0 plus 0 is less than or equal to 12. 0 is less than or equal to 12. That's true. So therefore, this is included. So I shade the part that has that. So it's everything below the line. Last two examples on the back of that page. When you look at this, again, I hope you see on example 5, the y is not by itself. So we need to make that happen. So I move the 3x by subtracting it, cancel it out. bring down, don't forget the negative 2y is greater than negative 3x plus an 8. Still want y by itself, so divide by a negative 2. And then pause for a second. Bring down the y and think, since I divided by a negative, what do I need to do? I need to flip the symbol. So instead of greater, now it's less than. On the right side, a negative over negative becomes a positive 3/2. And then a positive 8 divided by a negative 2 is a negative 4. Now we can graph. So I start at my negative 4. My slope is up 3 over 2, up 3 over 2. And then you'll notice that I'm erasing that because I was kind of jumping the gun. Since this is greater, it needs to be a dashed line. So make sure you're doing that right. Then the point that we want to test, 0, 0 is not on my line, so I can use it. So I want to see is negative 2 times 0 plus 3 times 0 greater than 8. So 0 plus 0 greater than 8. 0 is greater than 8. Is that true? No, that is false. Since that is not true, 0, 0 is not part of my answer, so it can't be above. My answer is everything below. So I would shade everything below that, the region that did not have 0, 0. There's my answer. Again, the graph is the answer. That dashed line and everything underneath it works. Final question, final example before I let you work on your own. Y is not by itself, so we're going to move the 5x over by addition. Don't forget that there's a negative in front of that 10, so bring that down. Is greater than or equal to 5x plus 0. Then we're going to divide by negative 10. And everything gets divided. Remind yourselves, since I'm dividing by a negative, what do I do with that symbol? Yes, flip it around. So y is less than or equal to negative 1/2 x plus 0 over everything is just going to be 0. So my y-intercept this time is right at 0. And then I'm going to go down 1 over 2. Down 1 over 2. And then because it is equal to, what kind of line will it be? Solid. A solid line like that. The one thing that makes this different, my usual test point was 0, 0. I cannot use that here. And I can't use it here because that's on my line. So it's my choice what I use. Let's pick any point maybe above the line. As long as it's not on it, it's okay. So I'm going to choose 0, 2. Okay? And that's just what I chose. I could use a different one if I wanted to. But that's not on the line, so it's okay to check. So I'm going to check 0, 2. So plug it into the original problem. Negative 5 times 0 minus 10 times 2 is greater than or equal to 0. Evaluate that and see if it's true. So I get 0 minus 20 is greater than or equal to 0, which is negative 20 is greater than or equal to 0. Is that true? No. That is a false statement. So that means that I'm not going to shade above, I'm going to shade below. Because that's the part that doesn't have that. So they're going to pass out the worksheet. There are about 20 problems that are just like these. If you need to, feel free to have the sub replay this lesson or go back to some specific examples. That's what it's there for. And then this will be due next time.